Hello everyone, my name is Austin Shaner, and welcome back to my channel. Each time one of my viewers reaches out to me about problems they are experiencing with their design, there's almost always one common denominator: splines. Many of you have noticed that I almost never use splines in any of my designs. So why is that? Well, this is my personal opinion, of course, but splines are seriously overrated. And this is coming from somebody who has used Photoshop and Illustrator both personally and professionally for almost 2 decades, so you know I appreciate a good Bezier curve. Splines are a fast and intuitive way to draw and manipulate complex and organic geometry, so it's no wonder new users to Fusion gravitate towards it. But are splines easy to define precise shapes with? Are they easy to hit tight manufacturing tolerances? Are they easy to make parametric for future design changes? Well, they could be, if you're able to calculate the polynomial functions that define spline geometry. But unlike Photoshop and Illustrator, where the primary objective is making 2D graphics that are pleasing to the eye, Fusion 360 is a software focused on product design, testing, and manufacturing. This is a substantial difference in methodology. The precision and tolerances of your shapes matter, particularly if you expect your components to fit together in a certain way, or will be using a machine to produce them. So why are the standard tools so difficult? Why do people find them so frustrating? Well, the standard tools require definition rather than free-form manipulation. They are more akin to a schematic rather than an oil painting. You draw each segment one by one, giving it dimension and constraints as you go. You start with a simple shape that has infinite possibilities and no relationships to the other geometry around it, and then restrict that shape until there's only one possible answer remaining: the shape you need. This requires more work and forethought, but often leads to a more desirable and predictable result. Predictability in CAD should not be underestimated, as having fully defined shapes sets the rules for all of our modeling tools. If we have a defined shape, we know what to expect when we loft along that trajectory or make changes to other dimensions in our design. Now, this is not to say that full definition is impossible with splines, or that there is no situation where they are the right tool. But knowing when and when not to use them is the real challenge. So today, I'd like to take a step back and cover the fundamentals of how to fully define your sketches. Hopefully, this will give you a better understanding of what you are instructing Fusion to create, and your sketching process becomes faster, simpler, less frustrating, and most importantly, fun. This way we free ourselves to let our designs dictate the tools we use, rather than forcing the tool we're most comfortable with to work for our design. So let's not waste any more time and dig right in. Okay, so jumping into Fusion, we're going to be modeling this little knife design that I created because it offers a pretty good example of deceptively simple geometry that is actually fairly difficult to constrain. But don't worry, we're going to start at the basics and work our way up, and then we will start making this up until a point of where we might notice that splines might be a good direction to use. So let's go ahead and open up a new design, and let's sketch on the front plane. Now, it is important to remember, let me back that up. It is important to remember that when you start sketching in Fusion 360, Fusion has no idea where you want your geometry to start from. So you can click any one of these planes, but let's say I just draw a line. Fusion has no idea where this line exists in space right now. It just drew a rough representation of a line, but you can move your start point. It doesn't know where that belongs. It doesn't know where the end point belongs, or how long the line between this is, or what direction that line is pointing. So like I mentioned before, what we need to do is we need to give this line either some relationships to a known point on the sketch, like other geometry or the origin point, or we need to give it some very specific dimensions so Fusion 360 knows what to do with it. Now, it is pretty good design practice to always start your sketches from the origin point, because that is one known point on the sketch that Fusion provides for you. So if we know that we want the start of this line to start at the origin point, we can either drag it onto there and it will automatically apply a coincident constraint, which is right here. What that does is it locks that point at where these two intersect. And so now I can move everything around except for that point. If you didn't want to drag it, you can always come up here and hit coincident and then choose each point individually and achieve the exact same thing. So now that we have that point locked down, now we either need to define where this point, the end point falls, or what direction this line is pointing in. So oftentimes you can like hit the vertical constraint, horizontal vertical constraint. And if you hit that, it'll snap to whichever it's closest to. So if it's closer to vertical than horizontal, like past a 45-degree angle, it will snap to that. So since that was closer to vertical, it snapped to vertical. But if it was closer to horizontal, let me click that, it'll snap to horizontal. So now we both have the start point, the direction this is pointing in, but now it doesn't know how long that line is or how far away this start point is from the end point. So what we can do is give that a dimension, and we can say 6 inches. So now you'll notice that everything on this sketch has turned black. And that's really important to remember because blue lines and white dots, so if I back this up, blue lines and white dots represent underdefined geometry, which means there's still freedom of movement somewhere. And that can be really important to remember because if you have underdefined geometry and later on you go and change dimension of something else, this is free to move and your sketch might go a little haywire on you. So it's always good practice, and I would set this as a goal for yourself, is when you leave the sketch, every line, as much as humanly possible, should be black. So that way everything is fully defined and you won't run into issues later down the road. So let me go back and hit horizontal, and let's make this 6 inches. So now this is fully locked down. I'm clicking and dragging it. I can't move anything. So that's good. That's exactly what we want. So now let's try drawing an arc and connecting this to that line. So arcs are a little bit different because they do have a start and an end point, but you can't just simply draw a straight line between there. There's a radius here. So there's one additional freedom of movement that you need to restrict. So let's say we want this arc to be, the start point of this arc to be connected to the end of this line. So we can hit coincident and close those together. And now Fusion doesn't know what direction that arc is pointing in. It doesn't know what the radius is of that arc, and it doesn't know where this start point is supposed to fall, or where the center point is rather. So what we can do is, let's say we know that this arc needs to come perfectly tangent to this line, so that way it's one smooth transition from that line into that arc. So I can select both of these lines and come up here and hit tangent. So now we've given that a relationship to this line. Not only is the end of this arc touching this line, it has to be tangent. So we've given it some set of rules. So now you'll notice that that line can't come untangent. And so really just what we need to define is what is the radius here and where does this point fall. So let's say I give this a radius of 2 inches. You'll notice that that is now locked down. I can't move that arc, but I can change where that endpoint falls on that circle. So if I wrapped it all the way around, it'd make a perfect 2-inch circle. Or sorry, a 4-inch circle. But what we can do instead is, let's say we wanted to define the distance here as 1.5 inches and the distance here as 0.5 inches. So we could totally do it that way. If we back that up, we could go 2 inches and then say 0.5 inches. It really just depends on what you care about in your design. Do you care that this is a specific size radius, so the design intent, or do you care that the endpoint lands a 1/4 inch from the top of the line? So I can then, let's say, draw another arc, and let's go the other direction. And what I'm going to use is I'm going to use the center point here as an endpoint. And so now I have both my start point and end point defined, but I don't have the radius of this arc or the direction that it's pointing in. So I can go 2 inches again. And now this is fully locked down because we have our start point, our end point, and what is the curvature in between. Now, most of your sketches will be done with lines and arcs, but occasionally you will use especially rectangles and circles. So, for example, if I just draw a rectangle here, it automatically applies vertical constraints on each one of these, so that way it remains a rectangle or a square. Now, if I didn't want this line to be vertical, I could then come in and delete that constraint, and now that is free to move not vertical, and I can have a tapered surface. But if we leave that there for a moment, right now it's free to move, so I could lock that down to an origin point or one of my other sets of geometry. So let's go ahead and lock it down to right here. So I locked that corner to there, and now you've noticed these two lines turned black. So they at least have one form of freedom of movement restricted. So now you can tell that it doesn't know the height of this line or the length of this line. So if I dimension this, let's say 12 inches, this one over here now turned black because it can no longer move in this direction. And now all it needs to know is the height of this rectangle. So I could say 2 inches. Now, you don't have to dimension it this way. You can dimension it a different way. So let's say we don't care about the height here. What we care about is the distance between this corner and this corner. So I could say 12 inches between that corner and that corner. And you'll notice that this is still free to move in both horizontally and vertically, but the distance between here and here remains 12. So let's say I wanted the distance here and here. I selected a line. Here and here to be 6 inches. Now, it's not letting me do that because it can't go that far back. So let's say we want this to be 11 inches. So we've got 11 inches wide by 12 inches on the corner. And that's a way you could dimension that as well. You likely won't dimension things that way, but it really just depends on your design intent and what the particular design you're drawing, the constraints you want to give it. So let's go ahead and delete all of this. Now that we've got some of that out of the way and you guys understand kind of the core concepts that dimensions give specific criteria to a line, arc, circle, etc. And constraints are basically a set of rules that the shapes have to follow when you're giving dimensions. So that way, what you change, you get an expected result. So let's go ahead and start working on the knife, and I will go into more detail about some of these dimensions and constraints as we go. So I'm going to draw two rectangles that are coincident at the top corner to the origin point. Do this, and make those coincident. And then I'm going to make these 2 points coincident as well. And the reason I did this in two separate rectangles is this will give me the ability to have some construction geometry. So if I highlight those and hit X on my keyboard or come up here and hit construction, that'll change it to a line that won't impact our geometry or won't impact our sketches in terms of extruding or building a model, but it'll just give us some helpful lines that will help us get some of our geometry in place. And the reason I did it in two halves was because this will give me the option to define my handle length and my blade length. So I can say I want my handle length to be 5 inches, and I want my blade length, let's say, to be not 5 inches, 4 inches. And let's say I want my blade to be, let's see, 1.125 inches deep. So this is covering basically the outline of my knife. And now we can go ahead and start drawing the shapes. So I'm going to draw a line here. We're going to start on the actual edge first. And I'm going to draw a line out and then come up here and draw an arc from here somewhere up here. And you'll notice as I highlight it down, I get a tangency constraint right here, which means it's automatically going to apply. But I'm going to click off of it because sometimes it'll become tangent to this line rather than this other line. And now you'll notice that I've got two lines sitting on top of each other. And this is one really helpful tip that I've discovered, that if you've got two lines on top of each other, and let's say you're having a tough time selecting them, if you click and hold down on top of them, you can then hover over and decide, okay, which line am I actually trying to select? And so that way I can say, I want to select this line, not the one that it's on top of. And then I can select this and hit tangent. And then let's go ahead and define a point. How far down? We're going to be doing a drop point knife. So how far down do we want that drop to be? So I'm going to say from here to here, we're going to do 0.375 inches. And now the only thing it really doesn't know is what is the diameter or radius of this arc. So I'm going to give this a 2-inch radius. So that part, the edge part of my knife is already done. And so now what we can do is we can do the top. So I'm going to give myself another straight line. And I'm not going to make this vertical to this one because I actually want this to go a little bit further back. So I'm going to go ahead and do the same thing, another arc from here to here. I'm going to hover over this or click and hold and then select the line that I want, which is this one, and then hit tangent. And that's already solved. So because we had our start point and our end point, actually, I apologize, it's not solved yet because we didn't determine where this line is. So let's go ahead and give this a radius of 6 inches. There we go. So now it's solved. So we didn't need to dimension these lines here because there's only one point on a 2-inch radius from this point to tangent to this line, basically, how long that line can be. Now, obviously, this is a pretty simple blade shape. Maybe you want something that's got a bit more of a recurve to it. So like, let's say I did another arc from here to here. I'm just going to do this for example here. Maybe I wanted my blade to look more like that. Now you can totally do that with the standard sketching tools, and you can just make these tangent and then define, their starts and endpoints, etc. But whenever you start to get into complicated S curves, let's say, where it swoops back up, back down, etc., that's usually a pretty good opportunity to evaluate whether or not you want to use a spline or not. And whether, depending on the complication of the complexity of the shape, maybe a spline is the right tool, or maybe do you want to invest the time to fully constrain this? So thankfully, this one is actually fairly easy to constrain. So I could make these concentric, and then I can make these concentric. Actually, I can't make it concentric, I can make it tangent. And then I can just define what is the radius of this arc. So I could say 2 inches, right? So I've got a 2-inch circle, the 2-inch keeps coming up into the transition, and then a 2-inch back. But what you could do if you wanted to is a spline. So we could do a fit point spline or a control point spline. So I could say, let's go here to here to here to here, and hit OK. And now I have the opportunity to control these with these, I call them tangency grabbers, but that's really not the right term, the T of the T-spline. And I could then drag that until I have a shape that I'm pretty comfortable with. And I don't really have to dimension anything to get a decent result. But there is a major problem with that. So let's go ahead and delete that line segment. Never mind. Let's make these construction lines so we can see it a little better. Do that and that. That gets us pretty close. So you can actually apply constraints to the T-handles of the spline. You can't really apply many constraints to the line itself, but you can do it to the T-handles. So let's say I wanted this to be tangent to this circle. I could totally do that. And I could say I want this one to be tangent to this circle. And let's say this one tangent to there, and this one tangent to there. And that will help me align the shape better. So this is actually a way that I will sometimes use splines, where I will draw construction geometry and then use that to constrain my spline to help me get some better results. And then really all you need to do to fully constrain the spline after that is to give dimensions to those T-splines. So let's say I do a 1 inch, and let's do 1 inch, 1 inch. Let's see if we can get this to turn black. Let's see, where's the freedom of movement at? I'm trying to drag these around. It looks like there's no freedom of movement, but Fusion is not wanting to constrain that. That's okay. Sometimes Fusion has problems going constraining splines, which is another reason why I don't like them that much. But if you do run into that situation, you can click your spline and hit Fix Unfix. Basically what this does is it locks that in place. So even if I didn't have dimensions, so if I delete all these spline dimensions, let's get this a little bit closer to our shape. I could then hit Fix Unfix and it will basically force it to be fully constrained as it's currently drawn, regardless of the dimensions you gave it. And that can be really, really useful when you're having trouble fully defining both a spline or an arc or anything like that, because you can also do that with arcs as well, arcs and lines, etc. So I can make that a fixed line regardless of what I drew it. So that's a helpful tip. And let's delete this spline because we're not going to draw this as a spline. And let's delete that, delete that. Let's make this not a construction line. And okay, now we're back to where we were. So now we can draw the handle. So the handle, I'm going to do an arc from right here back, and I'm going to make it tangent to this line right here. And then I'm going to say, where do I want this to fall? Do I want this to fall at the same depth of here? Well, if I wanted it to line up with this one, I could just make those horizontal, and now that is fully constrained. Or maybe I don't want it to go that far down. I can go 0.25 from that top line. So I'm recessing this line by 0.25 inches. I'm going to go ahead and leave that one there. So now what we can do is do another arc. So the blade comes to here, and I can draw a coil or a choil. I can never remember how you're supposed to say that. Basically, it's a little notch that you file in that allows you to sharpen the entire length of the blade rather than running into the material at the end. And so I could say, okay, what is the diameter of this? And a good way to think about this is, what tool are you going to be using to file this in? So if I'm going to use a 1/4 inch file, then I can give this a 0.125 inch radius. And then how far into this blade am I going to carve that? Now, if I'm going to carve it exactly half of a circle, then I can take this center point line, click on the construction line, and make those coincident. So that means that exactly half of the circle will be notched into it. If I didn't want that, then I could give like a dimension from here to here. Or what I could do, which is, this is a cool trick that many people don't know about, is you can dimension to the tangency of an arc. So if I dimension from this line and I hover over this arc and I right click it, right now if I just dimension it from here to here, I'll show you what happens. Oops, sorry. If I dimension from here to here, it's going to dimension from the center point of that arc to that line. So it's only giving me, you know, a 32nd of an inch or something. But what if I wanted to dimension from this line to the highest point of that? So hover over it, right click, and say pick circle arc tangent. And now when I hover over it, you can see there's a little X right here. So it's snapping to that. And now I can dimension to the top of that circle. So if I said I only want it to go in a 1/16 of an inch, I could do that. Or 0.09375, or I can go the full 1/8. But if you're doing that case, then you might as well just make these coincident. Okay, so I'm going to give myself a little bit extra material here, and we'll make that 1/8 of an inch. And now we can go ahead and draw our handle portion. So let's create another arc from right here to here. And again, we don't know where the endpoint is, and we don't know the relationship to this line right here. So what I'm actually going to do is I'm going to create some construction geometry up to right here, and I'm going to make those tangent. And what that's going to mean is that by the time it comes to here, it's going to be coming fully perpendicular to this bottom line. And then I'm going to give this a radius of 0.625 inches. And then actually I'm going to take away that tangency. I lied to y'all. Sorry. what we are going to do is we're going to draw another arc here. And I'm actually going to go a little bit past this. I'm just going to drop in a little bit. And then I'm going to connect these. So I'm going to make it tangent to here. And then what I need to do is give these some more radius dimensions. So I'm going to say I want this one to be 2 inches. Now where does this point fall? So I'm going to say 0.25, or what I could do is say I want it to be the same as whatever was recessed here. So I can, while this is hovering over there, I can click that and say equal to D20. And whatever I change this to, it will then change that to as well. I'm just going to leave it that way. And then what is this radius here? So I'm going to say 6 inches. Come on, there we go. And now it just needs to know where this point falls, really. So I'm going to give myself, let's make this not construction. And I'm going to give myself another helper arc from here to here. And what I'm going to do is I'm going to make these two concentric. So now it's basically forced onto a path all the way there. And now it just needs to know what is the height here, right? Because you can see it can go further down in height. So let's say I only want that to come up 1/8 of an inch. Well, that doesn't leave us much with a finger mark. So let's go 0.25 inches. That's too much. So let's do something like that. And there we go. Let's go 0.2125 and see. That's looking much better. I'm fairly happy with that. Maybe we can make this a little bit bigger. So let's go 7. Nope, it won't let me because of the way I constrain this, because that will probably end up being a straight line. That's fine. We can work with this. So now I've already got that modeled. So now what I can do is I can extrude this, and let's go symmetric. And we can go 0.125 inches. Actually, because we extruded that symmetric, we don't want it to be 0.125. We want it to be 0.0625. So that way my blade length, or my blade width, is 0.125. Hit OK. And there's actually something I forgot to do in the sketch. So let's go back to that real quick. And let's create a line from the center point here to the middle of this arc. And what that's going to do is that's going to set where the bevel is going to start and end at. So as it transitions into the bevel of the blade, it'll start right here and then taper all the way up to the point. And then that also gives us information on where we can place our handle. So we don't want our handle to go past that. So what I'm going to do is I'm going to create an arc from right here up to, let's make sure it goes onto this construction line here. And then let's bring it back. And let's make it equal to this line right here. So 2 inches. And it just needs to know where that line is going to fall. Oop, it's getting away from me here. 0.125. I lost my equal constraint. So let's click that and make those equal. And so that way we know that our bevel will sit in front of our handle scale. So let's just go ahead and hit OK. Actually, one more thing. Let's add an additional arc from here out. And the reason I'm going to do this, I will show you guys in a moment. I'm going to make those concentric real quick. Ooh, that went way out there. And I'm just going to give that a dimension so it locks it in place. And the reason I'm adding that arc is because we're going to be sweeping a cut along this handle. And I want that cut to go past so it doesn't end up missing this little back corner. So I figured that out ahead of time, but we're going to do it for you guys right now. So okay, let's create a new component so we can start working on the handle scales. So hit OK. And then what we can do is bring back our sketches, hide our bodies, and we can extrude this out, the thickness that we want our scales to be. So I'm going to do 0.3125. So let's do negative 0.3125 so it goes in that direction. Hit OK. Bring back our bodies. Now it's overlapping it right now. So I'm going to drag it out, and I can say joint. So I can click those two lines and hit J on my keyboard. and it will snap those two together and lock them in place. I will do a video in the future more about joints because they're very, very powerful, but essentially they are like constraints for components rather than sketches, if you want to think about it that way. And then I'm going to create a mirror of this component, so this object, across this plane. Oop, I selected the face, I didn't mean the face. The bodies. Across that plane, hit OK. And now I'm going to join that one as well. Come on. Create mirror, body, plane. Oh, it's not letting me because it's already joined. That's why. Okay. So let's go back real quick. Sorry about this. Let's delete the mirror and delete the joint. And what we can do is create a mirror of this body. Actually, not body, component. That's what was happening, because if you mirror a body doesn't need any reference because it's just in space wherever it is. But a component can be joined. So let's do component, mirror plane here. That component, hit OK. And now both of these should be able to move. Yep, that was the problem. I apologize for that. So let's join those together and join these together like that. Okay, so now we have our rough scales, and now we just need to contour them a little bit so they're more comfortable in the hand. So I'm going to sketch on this mid plane right here, and let's project in the geometry we care about. So let's project that in, and let's project in this back line because we need this to extend all the way back to there. And so what we'll do is we will close these off, and we'll make this one a construction line. Now you'll notice that these automatically constrain themselves because we already had our start point and our end point, and it's just drawing a line between. So I'm going to do the same thing over here, but I'm just going to give myself a rough rectangle, and I want to make these horizontal, horizontal, and I'm going to delete that and make that vertical. And then I want this to be equal on both sides. So I'm going to say here and make those equal. And then now I'm just going to give myself an arc. So let's go create arc, 3-point arc, from the midpoint here on this edge to the midpoint on this edge. And then I'm going to make it tangent to that top line. So that way when we cut through, we get a nice, we cut away all this material on the sides here, so we get a nice curvature on all sides. And now all I need to do is sweep that cut back. So let me select these profiles here, and we'll go create, or solid, create, sweep. And then what is the path? So if I bring back my sketches and hide our bodies and our components, I'm going to use this as my path. So if I bring this back, you can see that it's going to come all the way to the edge there, but I actually need to add that as a path as well. That's why we added that, so it goes all the way back. Hit OK. Hide our sketches and bring back our knife blade. And there we go. So we've got a consistent height here on the back side and a not consistent height on the front side, but that's fine. Now, it did not adjust the mirror on that other one, so I might actually change that. So I'm going to go back and delete that mirror one more time, as frustrating as that is. Delete. And I'm going to now mirror this over. So let's go ahead and go create. Actually, you know what? We're going to apply some fillets, so let's go ahead and do that first. So let's apply some fillets. This needs to be rejoined because I deleted that joint. And let's apply some fillets here on these edges, right here, and on this edge only, not on that one. Actually, we can do it on that one too. That's fine. And then here, and we'll do the top face as well, and we'll just do 0.065. So it kind of softens that edge around the fingers, and it brings it in. And yep, we are good on all corners. So hit OK. And that's a pretty good looking handle. So before I go ahead and mirror this over, I'm going to show you guys how to do kind of an emboss or an inlay on here, and that we might end up using a spline for. So let's take a look at that. So what I'm going to do is I'm going to come up here to Insert Canvas, and then I'm going to say From My Computer, and I'm going to use this little filigree that you saw earlier. Hit OK, and I'm going to insert it on this front plane. Now what I can do is scale it and rotate it. So I'm going to say 2.5, and let's go ahead and move it into position real quick. So we're going to do it on this back section right here. And let's rotate it so it fits the contour of our body a little bit better. Of our scale, I mean. That looks pretty good. Might go up just a little bit. Rotate it a bit more. That looks good to me. Hit OK. All right. So when you're doing stuff like this, this is a really good opportunity to evaluate whether you want to use a spline or not. Because if we're going to be tracing out this shape, this is a really complicated shape, and it doesn't necessarily use perfect circles or arcs. So in this case, I would probably use a spline because it's going to be far faster for me to draw this shape with a spline than it will be with the standard set of tools. But also, I don't really care about the dimensions so long as the overall shape is captured, right? The essence of that shape is in the design. Now, if I actually really cared, like the arc from here is 2 inches and it's sweeping along a very specific path, then I would probably invest the time to go ahead and dimension it and sketch it with the proper tools. So that way I could update something later if I wanted to. But since you don't care and you're just basically tracing out a generic shape, a spline works great. So what I'm going to go ahead and do is I'm going to insert a plane. So construct offset plane from here. And I'm going to go out 3/4 of an inch to give myself a little bit of a gap. And what we're going to do is we're going to draw that shape on that plane and then emboss it onto this surface. So let's go ahead and sketch on that plane. And let's zoom in. And when you use a spline, there's really 2 different types of splines you can use. There's a fit point spline and a control point spline. I generally prefer to use control point splines for my main geometry that I'm trying to draw. And then anything that I need to fill in the gaps with, I will use a fit point spline. A fit point spline, if you're not really aware, is you just drag points and it will start creating constant curvature between all of those points. And so that can be a really fast way to get a decent result. So like if I wanted to click here, then here, and keep going around that circle, it'll start to follow that circle pretty well, right? Oop, let me undo that. I accidentally lost it. Let's go back to sketch on that plane. Sorry about that. And let's do that again. So if I go fit point spline and I draw it, we can stop here. So you'll notice though that now I have to come back in and adjust these, and these knots that are in the line are straight in line with the spline. And so if I drag this out, you'll notice that it's bending the other one back in. Whereas a control point spline, where that kind of differs, is the knots aren't in line with the spline itself. They sit outside of it. And so I can then draw basically around the shape like that. And then I can use those and manipulate those until I get the shape I want. And it's usually, for me, I find it to be significantly faster to get the shape that I want using those. So that's what we're going to do. We're going to trace the outline of this. I'm not going to do all the fine details inside because that would take a while. And I don't think you guys have the time for it. So let's do a control point spline. Let's start here. And let's try to draw around this really roughly. And one of the key points with control point splines is that you want to try to keep the knots or the control points as equidistant to each other as possible so you don't get any weird results. And I'll hit there and hit OK. And now let's just adjust these real quick so we get the shape that we're after. So let's drag, oh, that one's not quite enough yet. Sometimes you have to skip one to be able to get the shape you want. Let's bring those in. Okay, I think you guys get the idea. So I'm going to do a time lapse here. Speed this up a little bit so you can see me doing this a little bit faster. Okay, phew. Thanks for sticking with me on that. Now, because we're basically estimating the shape, we're not providing precision tolerances or anything like that that needs to be hit. This is totally fine to do it this way, and this is I would consider a very good use of a spline. It saves you time. It's an easy way to estimate the shape, but you don't need to provide specific definition. So in this case, what I would do is I would select each spline, select all of these, and then I would just go fix, unfix. So that way it locks it in place for me so I can't accidentally change anything going forward. So now what we can do, since this is now a closed profile, is either emboss it onto that surface or do a extruded cut. So typically if you want to do an emboss, now for some reason when I was developing this video, the emboss feature wasn't really working for me in this case, and it might be because of the way I swept the cut on that face. But typically you can say emboss, then select the face you want to emboss it on, and it will automatically wrap it for you. You can see it applied it on this axis. And it can apply it for you either as a cut or an emboss, and it will maintain its relationships. But in this case, it won't let me select that face. So I'm not exactly sure why. So what I'm going to do is I'm going to extrude. So let's go extrude with this face, and we'll go to object, that front face. Now what we can do is go offset of negative, let's do 0.02, just to give ourselves a little emboss. And you'll notice because I did to object that it's not cutting a flat shape. Let me bring that back again. It's actually hugging the curvature of the blade itself. So it's maintaining that 0.02 down into that body. We didn't have to, so if I take off to object, for example, and I just go distance down, you can see that it's actually remaining flat on the bottom. But because I did the to object here, it's actually creating that curved surface for me, which is great, which is basically doing the same thing as an emboss. And I can hit OK. And let's hide our canvases. And that looks really great. Now, if we wanted to, let's say we cut this out with a ball end mill or something later on a CNC. I can then apply a fillet. In fact, actually, let's just close this and select that bottom face. And I could say 0.02. Now, that's a little too big for that relief. So let's go 0.0159. Yeah, that looks a little bit better. So that way, if we ended up cutting that with a ball end mill, we'd be fine. So there we've got our little bit of an emboss, and now we can go ahead and mirror this shape over. So let's go ahead and grab the component and go create mirror on the mid plane. Make sure it's set to components to avoid our catastrophe earlier. Hit OK. And now I can join this to the body like that. And let's go ahead and hide our sketches and apply some appearances. Let's go wood, and we'll do glossy cherry. That always looks really nice. And actually, there's one critical thing I forgot to do, and I apologize. I didn't put the bevel on the knife. Stupid me. So let's go ahead and bring back our sketches, and I will show you guys how to do this. what I'm going to do is I'm going to create a plane at angle on this line right here. And we actually don't need to adjust the angle because it's already perfect. And so that's where the bevel was supposed to start. Hit OK. And let's sketch on that plane. And let's hide our scales real quick. And now all we need to do is project in this line. And let's first draw what we want that bevel profile to look like. So let's project in that line as well. And draw down. And this is going to be where we talk more about constraints. I apologize. This has mostly been just regular modeling for a little bit. And connect up to here. So these are just a series of straight lines. Now the question is, how do you get these to be equal and at the same angle with each other, etc.? So what I'm going to do is I'm going to dimension from this center line right here, and this is going to set your bevel angle of your blade. So let's do like 25 degree. That went a little crazy on me. Like that, and we can make these two equal. That, and let's make these two horizontal. Right here. There we go. So now that blade angle is set. So now I just need to define, well, how far back into the blade do I want it to go? So let's do 32nd of an inch, like that. And everything else is already fully constrained because we have our start point and our end point that we just defined, and then basically our breakaway angle for what you would sharpen it on. And so in order to do a cut like this, I just need to give it some sketch around it. So let's draw like this, back up to there, come out a little bit further, and draw up to here. And now I can just go the horizontal vertical constraint on all of these. And everything is already fully defined. So now I can just sweep this cut up this path. So let's bring back our sketches. Actually, we already have it. And let's go solid, sweep. And for the path, we're going to, let's hide the body. Let's use this path and here. Bring back the body. Now you'll notice that it's actually not coming all the way up. So we may have to provide another helper line that goes up on that, like we did with the other one. Yes, because it's actually, that's because we didn't connect it. So what we can do instead is on our original sketch, let's exit out of here. All we have to do now is just connect this to here with a solid line. Now if I do it and I go back and I hit sweep, like that, great, sweep. And for the path, I can choose this line, and let's hide the body so I can see it, and this line. Now it's connecting. So what was happening is there was about an 1/8 or a 1/16 of an inch gap or so, maybe an 1/8 of an inch gap. And that's how much it was missing from this angle, because it was basically taking this whole path and sweeping it or offsetting it back a little bit. Hit OK. And so now we've got our blade angle, or our bevel on our blade. So let's go ahead and bring back our handles. We've got the little emboss on both sides. And let's apply let's do black oxide to the handle, or to the blade. Let's kind of simulate like a DLC coating. And let's make it a little bit brighter. And then let's do a chrome on just the bevel, because or just not the bevel, but the actual part that we sharpened. And we'll select faces, and I want to apply chrome just to those faces because they will be polished after we've finished stropping and sharpening them. Hit OK, and let's go back to render, and let's change this a little bit. Actually, let's make this the top view. There we go. And then let's change our setup again real quick. See if we can get a nice reflection on that edge. Let's see, where's that reflection strongest? Let's say probably right about there. That looks pretty good. Okay, and let's change our background color. Make it something a little darker. So let's go here. That, and okay, and render this up. So that was actually a really good exercise on understanding sketch constraints and also making a pretty cool little model. You can see this little bevel here, or not this bevel, this little emboss feature we put on there came out really nice. And I hope this helped you guys understand some of the case or the uses for splines versus the regular tools. Because when I use the regular tools, it's because I care about the dimensions of what I'm drawing. When I don't use it and I reach for the spline, that's usually when I'm dealing with geometry that I simply just can't constrain with the regular tools, or it would take me an astronomical amount of time to do. And so for me, that is the benchmark, is it worth my time to go through and constrain it? And if yes, then I will do it. And if it's not worth my time and I want to just capture the essence of whatever that shape is, then I will reach for a spline. Now, I did mention at the beginning, you can actually do the math for how to calculate these splines and Bezier curves and B-splines, etc. If you're interested in finding that out, you can just look up Bezier curves on Wikipedia, and that will give you a lot of great information on where to start with that. I am not a big math person, but if you are, what you can do is you can calculate those and actually draw and dimension all of your control points exactly how you want, and it will generate the perfect spline for your shape. So if you're a math nerd and you want to get into that, feel free. It's not for me. So before we close up this video, I would just like to say thank you to Dave from Belmont, North Carolina, who requested this topic. I hope this helped you, Dave, and everyone else who struggles with the principles of constraining sketches and knowing when and when not to use splines. If you'd like to support this channel and help me continue to provide high quality content, you can find me on Patreon at patreon.com/Austin Shaner. You can either provide a custom donation or choose from one of my 3 tiers, which will give you access to my video schedule, digital downloads of the files created in each of my videos, as well as a live Q&A with me once a month to help me decide which videos to prioritize. If you'd like to chat with me or submit a request for this channel, you can reach out to me on Discord or send me an email. Links will be in the video description below. But thank you all for coming. This is Austin. I'm signing out.